Hello, I am Henry. Here's my presentation video of Code 1110 Assessment 2. My case study is about CITA Hybrid Tower. Here's the content. I will present from the case basic information, then go through every key design elements in this project. First of all, the tower was built in 2016 with an area of 7 square meters and the height of 9 meters, and it was located in Portugal. The stakeholders include the design team CITA, Center for Information Technology and Architecture, as well as its knitting company AFF, and so on. The tower was built with the historical background of the traditional thinking in architecture, which is about to understand the building as static appearance that is not affected by a change of environment. But this tower explores this idea of a fluid architecture, a resilient structure that adapts under environmental changes. This tower possesses a very unique structure and form from both outside and inside. For the outside structure, it is generally constructed by two components, the bent GFRP rods and a custom-made CNC knit as a membrane covering the whole surface. It creates a series of single triangle units to generate the building surface, and each unit is sunken in the center, and by stacking these upside-down units, the whole surface has been generated, which is very stable and also lightweight. For the inside structure, it is quite complex compared to the outside, as there are lots of metal rods and rings within the building, and the purpose of this is to give the tower an inner support, so that to holding the whole surface. This is a key design method to make sure the stability of the building, as well as keeping its lightweight, and I drew a series of diagrams to explain this. The left diagram is the view from the top of tower. In this diagram, the straight lines means the metal rods, and the circle means the inner surface of building. So we can see the rods hold the surface horizontally to keep the stability of tower, and they gather finally at a point in the center. And the diagram at the right shows the same work as the vertical direction, with these arrows means the direction of force. And this unique structure gives it a great environmental effect. This uneven surface increases the contact area of wind, and also, with the help of membrane material, this can make it easier to be changed by natural wind. The diagram below shows this impact. In this diagram, the big arrows represent the wind, and the small arrows represent movement of surface. So when there is a strong wind blowing, the building surface can move following the direction of wind, and this is what we call a fluid architecture, which possesses a better performance to adapt with the environment, as well as withstanding more wind force, both vertically and horizontally. The materials used in tower are highly customized. Therefore, they usually have a better performance which fits to its structure. And as the main material used in tower, the production of membrane has been innovated by using CNC knitting machine. And by using this way, the membrane can be made in a shorter time and a better economic benefit. The knitting machine also provides an accurate control to the material. And with these advantages, architectural details can be integrated directly into the membrane materials, as the picture showing at right. The connection of each section materials are produced together with the membrane smoothly and completely. So there are basically two digital technologies, including the use of computational tool and CNC knitting technique. The design team developed a set of related computational tools in order to design and specify these material systems, and this created a design platform for the tower. For the CNC knitting techniques, as I mentioned before, it is the key digital method in the production, which is a combination of traditional CNC technique and knitting materials. It works by following coded program instructions to create textile. This is a more accurate and faster way without the manually operation to the machine. And the digital technologies also has significance to almost all of the production process. The diagram shows its relationship. You can see from the stage of design to material creation, computational tool supports a digital platform to attempting the form and materials. And besides, it can establish the database for further analysis and test. The CNC technology basically works at the step of material creation. It plays a role of production and directly control to the materials. And with this help, the materials can be carried out smoothly and rapidly. Here are some photos of the physical model. It is organized by several single triangle units which are mated by using timber sticks and trace paper. Then I connect them in an upside-down arrangement to simulate the tower surface. Finally, I put them into a circle as the final model. So this model can interpret the method of tower design in a simplified way. As conclusion, CITA Hybrid Tower is a pretty successful design, combining the digital technologies and building constructions. It opens a new avenue for textile as a building material to create soft structure. And I've learned that computational tools can give the building a new life, as it can break in the traditional recognition. It gives a new meaning, whether in aesthetics or practicality, or even the intervene for old building environments. So that's all of my studies. Thank you.